Me and my group would like to present about the engineering components and mapping pipe. For the agenda, we have introduction, objective, methodology, data analysis, discussion, and conclusion. For introduction, screws are mechanical fasteners characterized by their helical or spiral threads which wrap around a cylindrical shaft. These threads enable screw to engage with complementary threads in a tape hole or nuts, creating a secure and reversible connection. A nut is a small round metallic ring. Talking about the nut shape, the nut is not a mere round metal, but it is shaped very differently from other basic round metal. Like you can see beside me has the photo or the picture of nuts and screw. For objective of this project, we have 4 objectives. At first, to name and measure all the engineering components or mapping pipe. Second, to compare and evaluate the accuracy, reliability, and consistency of the profile projector for measuring the parts. Third, to achieve high precision in the manufacturing process to meet tight tolerance. Precision is critical to ensure proper fit, alignment, and performance of the mapping pipe within the system. Lastly, to determine the precaution to be taken for accurate measurement.
For methodology, we use 2 tools for measurement. For the first one, we use digital vernier caliper, and the second one, we use vertical profile projector. For the digital vernier caliper, a digital or electronic caliper is a precision instrument used to take very accurate measurements. It is the most recent innovation in caliper technology. Measurements can be clearly read from the caliper's LCD display. The LCD screen takes the place of the die indicator of the die caliper and the vernier scale of the vernier caliper and makes the digital caliper much easier to use. Digital calipers are also able to take more accurate measurements. Most are able to measure up to 0.01 mm. The zero button enables the user to zero the caliper at any point. These features make calibration much more straightforward than with other types of calipers. And the second one, vertical profile projector. Profile projector is widely used for complex show stampings, gears, cams, threads, and comparing the measured contour model. It's easy to use and highly efficient. It is commonly used measurement of optical instruments. Thus, profile projector is widely used in major machinery manufacturing, including aviation and aerospace industry. The projector magnifies the profile of the specimen and displays this on the built-in projection screen. On this screen, there's typically a grid that can be rotated 360 degrees, so the XY axis of the screen can be aligned with a straight edge of the machine part to examine or measure.
As you can see, this is the table of the disparities in pitch measuring between standard and actual pitch. Factors such as the intended application, material qualities, and manufacturing constraints dictate the typical pitch of a tube. Pitch variation can have an impact on vibration resistance, load-bearing capability, and heat engagement. Variation may occur accidentally as a result of production tolerance or on purpose for a specific purpose. The space between neighboring tubes determine an object pitch. Finer tubes are produced by lower pitch and Coarser kits are produced by larger pitch. Depending on the particular application, different pitch kit might have an impact on things like torque recruitment, stand, and assembly case. In order to guarantee the precision and dependability of measurement in a variety of domains, calibration, repeatability, and reproducibility are essential ideas. In order to identify and address any deviation, a measuring device or system must be calibrated by comparing it to a standard reference. It guarantees that the device will continuously produce measurements that are precise and reliable, preserving the integrity for the information gathered. The capacity of measurement system to produce consistent findings when measuring the same object again under the same system is known as repeatability. A system that is highly repeatable is indicative of lower random error, which enhances measurement dependability. Despite just being repeatable, reproducibility assesses how consistently measurements are made by several operators using various tools or in different labs. It lessens the impact of systemic fault by evaluating the system's capacity to produce consistent outcomes even when used by many people or in various contexts. Calibration, reproducibility, and repeatability work together to create a solid foundation for measuring system, while repeatability and reproducibility assure precision and consistency in measurement and build confidence in the usability of accurate data. Calibration ensures accuracy by aligning device with standards fundamental to production, research, and quality control produce. These ideas support the general integrity and reliability of industrial and scientific undertaking.
So now let's move to the data analysis. As you can see the data analysis over here, we have measured the three types of screw, which is small, medium, and big. For the small screw, we have measured the length, pitch, nut thread depth, angle between the nut thread, and head diameter. For the length, we have measured that we got the average is 90 mm, and for the pitch is 0.8144. For the nut thread depth is 0.3651. For the angle between the nut thread is 57.7 degree, and for the head diameter is 5.7085. For the nut is, we get the external diameter, internal diameter, and thickness. As you can see the value over here, we get the average is 5.40, and for the internal is 2.8164, and the thickness is 2.30. For the washer, we also get the external diameter, internal, and thickness. So you can see the value over here. We also, as you can see the data over here, we also have measured the flathead clip, a door arm clip, a door armrest clip, and a GM door.
Hi, my name is Yap Ising. My metric number is 230094. First, I need to talk about the criticals to quality CTQ variable. The project scope CTQs include criticals variables analysis, measurements instrument, and component converge. The projects include 3 different sizes such as both nuts, washers, and clip using a digital vernier caliper and a vertical profile projector. The critical to qualities variables are based on the material's size and shape, and the measurements accuracy, precision, and repeatability. A process machine is selected to meet these requirements, such as vertical profile projector for manuals, components, and the digital vernier caliper for seamless measurement. The product's durability and safety are also considered, with factors like materials and safety playing a role. The product's cost and efficiencies are also considered, with qualities affecting the cost. Thank you.
Last but not least, conclusion. To conclude this conclusion, when it comes to engineering component or mating parts, it's critical to identify and pay attention to critical to quality CTQ variables. The final product's functionality and durability are greatly influenced by the accuracy and dependability of these variables, ensuring that the engineered components or mating parts fulfill strict quality standards through careful identification and control of CTQs promotes both customer satisfaction and system integrity, ultimately attaining excellence in the design and production processes in this sector requires a strategic focus on CTQ variables. That's all.